In line with the principles of the European Union on the efficient and sustainable use of water resources, the LIFE-3E project aims to demonstrate the viability of an innovative circular economy strategy for the reutilization of water. In support of this daunting challenge, the project received European Union funding through the LIFE program in its announcement in 2019. The LIFE-3E project will carry out pilot in a real-world environment, making it a global pioneer. The prototype will be located at the sewage treatment plant in the Spanish coastal town of Comillas. The results of the project will make it possible to evaluate the potential implementation of this solution in coastal wastewater treatment centers in European countries and, by extension, in the rest of the world. LIFE-3E aims to demonstrate the potential of recycling effluents from wastewater treatment plants, or UWWTPs, in other activities such as street cleaning, industrial uses, and agriculture, avoiding the use of drinking water for these purposes. Furthermore, one of the most innovative characteristics of the project lies in the integration of energy recovery in the water treatment process. The pilot will demonstrate the potential energy savings in WWTPs, making use of the energy contained in the saline gradient or blue energy through reverse electrodialysis technology. This type of energy is obtained through the controlled mixing of two streams of different salinity, constituting a source of renewable energy. WWTPs located in the vicinity of either the sea or desalination plants are ideal locations for the implementation of this new source of sustainable energy. To achieve this ambitious goal, 3 levels of work will be carried out in a chain at the Comillas WWTP. In the first stage, the water will follow the process of a typical treatment plant. After primary treatment, secondary treatment will be carried out to ensure the effluent reaches the values required by the legislation for its discharge, in this case to the sea. At the second stage, a tertiary treatment will be applied to the water, consisting of disinfection and microfiltration. This treatment aims to achieve 2 objectives: increase the quality of the water for recycling and allow the water to be used in the next process of generating electrical energy through reverse electrodialysis. In many cases, this type of treatment is avoided due to the enormous energy cost it entails. However, in this case, it will be compensated by the installation of the prototype with an hourly flow of 1 cubic meter, which will reduce the cost of the process. Also, obtaining energy will not mean a reduction in water quality, since the technology is non-invasive and only involves a slight increase in the salinity of the diluted stream. Currently, the Comillas WWTP consumes an average of 220 watt-hours for each cubic meter of treated wastewater. Thanks to the use of the energy contained in the saline gradient, an average of 55 watt-hours per cubic meter is projected, reducing approximately 25% of the energy consumption of this process. At the third level, the outlet effluent will be delivered to the town council for cleaning the streets of the town. This will mean not only cost savings in terms of the use of drinking water, as is the case today, but also a clear environmental improvement, since the effluent will be given a new use instead of being discharged directly into the environment, reducing the pressure on resources from inland water masses. The environmental benefit in terms of the impact on climate change is potentially significant. Specifically, it could reduce the CO2 released into the atmosphere for each cubic meter of treated wastewater by up to 70.9 grams, which, if extrapolated to the number of existing treatment plants in the world, could lead to energy savings of 6 gigawatt-hours across the globe. The energy source produced by the project results from transforming the energy contained in the saline gradient between the treated wastewater and seawater into electrical energy. The saline gradient is achieved when two streams of water with different concentrations of salt are brought into contact so that an exchange of the ions contained in the salt can take place. In the case of LIFE-3E project, these currents are not mixed, but rather are introduced into an electrochemical cell where the ion flow takes place through a series of ion exchange membranes. The electrodes of this cell, by means of a suitable redox couple, convert the flow of ions into an electrical current that, when transformed into a direct current, can be used. The consortium is made up of 5 partners, 4 of whom are Spanish. The coordinator of the project is the Environment, Water, Waste and Energy Mare S.A. public mercantile company in charge of the management of water, waste and energy recovery and the maintenance of the territory in the autonomous community of Cantabria. They are joined by the Research Group for Advanced Separation Processes, experts in the promotion of new renewable energy sources such as the energy of the saline gradient and the design of optimal treatments to guarantee water quality, among other areas. The technology-based company Apria Systems SL is also an active partner in the consortium. They are a leader in the field of treatment, purification and recovery of liquid streams through innovative technologies. Finally, within Spanish territory, the Cantabrian Environmental Research Center, CIMA, offers its active cooperation as an autonomous body of the Cantabrian government. Its fundamental objectives are to provide the necessary means to ensure citizen participation and awareness regarding the different environmental issues, and to collect samples and carry out analysis for environmental studies in Cantabria. Together with these 4 partners, the German University of Darmstadt participates through its IWAR Institute, dedicated to the protection of water and the environment, with extensive experience in life cycle analysis studies. All the above makes LIFE-3E an innovative project within the field of water and energy, with the different approaches to the project providing benefits that will affect everyone. Socially, by advancing a new type of technology that can be used worldwide, contributing to the creation of jobs in renewable energy technologies. Economically, by reducing the operating cost of both potable and residual wastewater treatment centers. And environmentally, by reducing greenhouse gas emission, minimizing runoff to the environment, in this case, seawater, and increasing water quality, thereby favoring the conservation of coastal ecosystems. Finally, by reducing pressure on continental water masses, by recycling treated water and reducing the freshwater catchment needs. In summary, the main challenge addressed by LIFE-3E is to advance the sustainability of treated water regeneration systems by integrating them with technologies to enable energy recovery. The project is expected to have a significant impact on contributing to the fight against the climatic emergency, in addition to other environmental benefits, while providing solutions that favor the implementation of the circular economy in the integral water management sector.